Hey guys, here's what I hope is a short video continuing on the confidence interval for beta, is the significance test for beta. And the same conditions, which are linear, independent, normal, equal variance, and random, if those are met, in addition to the confidence interval that can be constructed, a hypothesis test can be carried out. The null hypothesis is going to be that beta is equal to a hypothesized value, typically 0, indicating there's no linear relationship between the two quantitative variables. But I guess it could be sometimes, the claim is that the slope is 10, and you would test to see that it's greater than, less than, or maybe not equal to. But in most cases, it's going to be the null is that beta equals 0, and beta is the true slope of the regression line that relates x and y, whatever that happens to be in your particular problem. And then the alternative may be less than, greater than, or a two-sided not equal to. The test, which is every test we've done, is the statistic minus the parameter over the standard deviation of the statistic, yet in the case of the regression line, we use the standard error. The statistic sample slope is b. The parameter we're estimating is beta under the null, and then we'll be dividing by the standard error that we get from b. That'll give us a t-score, and we will look that up in our t-table for n minus 2 degrees of freedom. Just same degrees of freedom as the confidence interval. And we'll calculate a p-value from that table, either on our calculators or using the table, to then decide whether we're going to reject the null or fail to reject. So I'll go through this example quickly, and then you should be able to tackle the SIG test for beta worksheet. In this particular example, we're looking at the relationship between number of crying peaks, so the count of crying, versus the IQ of a child at a particular age. And from the scatter plot, it seems to be a positive relationship there. And so we will carry out the test, do the data, provide convincing evidence that there is a positive linear relationship between crying count and IQ in this population. So we'll tackle this with our null, that beta equals 0, versus the alternative, beta is greater than 0. And it says positive linear relationship. So we're testing to see, is beta greater than 0? One-sided test where beta is equal to the true slope of the population regression line relating crying count to IQ score. And we'll use alpha equals 0.05 since we weren't given one. Hopefully that's fair enough. So that would be, step 1 if we're carrying out a 4-step procedure. We are going to use a SIG test T for beta. That's the name of the test. Or you can write T equals B minus beta over SC of B. So either by name or by formula. And in order to do this, we need to check our conditions. And I like to write liner to remind myself of the 5. The first one being linear. And the best we have is the scatter plot. Indicates, let's say, moderately moderately weak, positive, linear relationship between the variables. If we had the data, we'd like to create a residual plot to look to see if there's any pattern there. In the absence of that, we can just say we'll assume that in your mind's eye. Remember though, if you kind of box it around the line, there doesn't necessarily seem to be any kind of pattern that exists. When you kind of rotate it that way, it's not a perfect system, but this line would be residual equals 0. That's the line, and then the vertical distances would be the residuals. Again, not perfect, not by any means does anyone say, yeah, that's the way to do it, but you could at least say to yourself, yeah, I don't really see a pattern in there. But the best we have is the scatter plot, so we'll go with that. Independence. The independence it needs to be some comment. Because they were randomly sampled without replacement, we're going to say at least, and how many do we have? 38. So at least 380 infants in the population from which we sampled. That's our 10% rule there. And outside of that, because we're comparing these together, the later IQ scores of the individual infants should be independent. The normality condition is a normal histogram, or roughly normal histogram of the residuals, or you could make a normal probability plot of the residuals, and we're gonna assume, because we don't have that information, and I don't have the raw data to even put it in my calculator to figure that out. So as specific as we can be about our assumption, that we assume the distribution of residuals is approximately normal. That's the best we can say without the data or without being given a graph. Equal variance is our next condition, and that would be the residual plot again. Residuals assumed to demonstrate equal variance across X in the resid plot. Again, we'd love to be able to make a residual plot or be given one in this example. If I go back and make my fake one up here, what we're saying is that as we cruise along X, roughly the spread of these points is pretty consistent. The spread here, the spread here, the spread here, and the spread here. And this is not a dynamite example, but we're going to assume that that's met very specifically, that the variance in the residuals, or variability in residuals, the standard deviation of the residuals, is consistent along X. That's what we're going to say. Our random condition is, we were told that the 38 infants were randomly selected. All right. So just to recap, this guy and this guy are going to come from the language of the question. And let's see, linear and equal variance, we're going to want that to come from a residual plot if provided. And then separately, either a histogram or a normal probability plot of the residuals to assess the normality. That's where those are going to come from. Assuming all of that is good to go, we can go ahead and do our test. And remember, it's t equals b minus beta over SE of b. And we know from the table here, this is b, that's my slope. This is my y-intercept A up here. So my equation, not that I necessarily need this right this second, where x is cry count and y hat is the predicted IQ. My slope, there we go, 1.9, whoops, so close, 1.4929, 1.4929 minus, under the null, we said beta was 0, over the standard error of b, which is that guy, which is 0.4870. And so you can knock that out on the calculator, and looks like we get 3.07. Now what's really great about this test is earlier I told you, when you're doing a confidence interval, you don't use the t-value that's listed here. Well, now's the time. This value here, 3.07, is the test statistic. That's the t for this particular data set here. Now you can work this out, that's no big deal, but it's always going to be the number that is up here. And I guess furthermore, if I take that away and zoom in here, kind of the neat way to think of this is the coefficient, if assuming that beta is 0, that's the null, because you don't end up subtracting anything, that divided by that is 3.07, because beta was 0. So we end up with just b over the standard error. So that's going to be true if the null beta is 0. Now we have to go look this up in our t distribution and find our p-value. And it looks like our p-value with 36 degrees of freedom. Did I write that anywhere yet? No, we'll put that down. Degrees of freedom equals 38 minus 2, which is 36 degrees of freedom, is going to be 0.002. You could also look it up. This is from there's a number of ways to get this number, this p-value. One would be look it up in your table, and you could bound it between 0.001 and 0.005. So 0.001 p-value, 0.005. I'm not looking at the t-table right this second, but I think it's between those two values. You could come up with this one from the calculator, or you'll notice that it gives you a p-value in the computer output. The thing to be aware of is that this p-value is for two-sided. And that's always what the computer output is going to give you, is the two-sided p-value. Our problem, though, was one-sided. So even though that my computer output gives me the p-value on two sides, which is 0.004, I'm only concerned with the right tail part of it. So that's why it's 0.002. So make sure you're comfortable with that. The computer output gives you is the two-sided p-value. And if you're doing a one-sided test, you have to cut it in half because you only care about the one side. Now, this p-value, regardless of, even if you made a silly error, the p-value is less than our alpha. Therefore, we reject the null. And we're going to conclude the alternative. We have strong evidence to conclude that there is a positive linear relationship between cry count, or whatever it was called, and IQ score in the population. So much like the confidence interval, I would argue most of your work is going to exist here with the conditions, and this is, I mean, we didn't even have to create the residual plot or histogram of the residuals. We kind of just went forward and said we assume these things are true as best we could. The work that you end up doing is very silly easy. It's all right here, especially if the null is 0. The only thing to be careful of is whether it's a one-sided or two-sided test and whether or not you can pull that p-value. So if you're feeling good about this, go ahead and take a look at the SIG test for beta worksheet, and you should be all good.